Hey, PerfBytes listeners, before you get started on today's episode, we'd like to mention the generous support of our sponsor, Flood.io. Imagine your load test plan runs great with just 10 threads, but now you need 100,000 users. Distributed load testing seems like a good idea, right? But now you're wrestling with out-of-memory errors and blocked RMI ports, and your load generators outnumber the target servers for JMeter. You are throwing knives in the dark with limited feedback and Mandralic reporting. Say hello to Flood.io. Launch Flood test using JMeter or Gatling, view and share test results in real time, scale out your own grid across the globe in minutes. Flood.io, distributed load testing for everyone.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Don't book our PerfBytes.
Waffles, microwave ready.
Blobbity blah, blobbity blah.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson and James Pulley.
PerfBytes.
Whatever.
Hey, it's time for PerfBytes. This is Mark broadcasting live from the men's room at the International Space Station. And at least it kind of sounds that way tonight. I have a bit of a head cold, too. I got that summer head cold bug that's going around. Yeah, it just joyous.
Zero G will clear that right up, so don't worry.
Oh, okay, that'll be good.
See, I was thinking it wouldn't allow his sinuses to drain. You know, I guess I had that totally wrong.
No, I don't think so. But
oh, okay.
I did have some. I did eat something with horseradish though, and that was really good to blast out the sinuses. Nice, hot, kind of spicy thing. I think you could do the same with wasabi, but that's beside the point. Totally different.
And welcome back to Health Chat, folks. You're joining.
Yes. All right. Thanks for calling into the live doctor's line. We're going to talk about mucus creation.
Thank you, Dr. Dean.
Exactly. Welcome to PerfBytes. Our episode today, we're going to be talking with the Seth Eliot, our good friend Seth Eliot from Microsoft, who works as the principal knowledge engineer with the world's most awesome title. And we're going to talk about data-driven quality and data-driven performance. But before I do that, James Pulley, my famous, infamous, tall and handsome co-host. James, how are you?
I'm doing well, Mark. Before we begin, I would like to bring up that this is the anniversary of D-Day as we're recording this broadcast. 70 years ago today, Operation Overlord put tens of thousands of men and women on the shores of Normandy to take back Europe. And I think there's a lesson to be learned for all software projects.
Sure.
And you would think this is a logistics question or it's, one of manpower or something like. No, it all comes down to responsibility. Before the invasion, Eisenhower penned a letter where he accepted total responsibility for what was about to occur just in case it failed. I would like to find that project manager who will take full responsibility for what happens to the software in production.
Well, but James, if they don't know what performance means before they build the code and release it, how are they ever going to really learn what full accountability for performance would be after they launch an application?
Well, once they get fired a couple of times, they'll learn to ask those questions now, then won't they?
Well, that's the hard way to learn. I think there's a better way to learn, which brings us to today's topic.
Well, Mark, I learn by putting my hand on the cherry red burner. I don't know about you.
No, I can learn vicariously through others and the information that they share with me about what's actually happening on the stove so that I don't burn myself. And by the way, I'm very sorry about your hand. Now it explains a lot, that weird, you wear a glove all the time and you have a hairless cat.
Actually, that's my thing about Michael Jackson, but, that's a different story. But
that's a totally different story. I understand that, Dr. Evil. Seth Eliot, welcome to the show. Welcome to PerfBytes.
Well, thank you. I appreciate your introduction where you introduced me as the Seth Eliot. I'm going to insist on that going forward.
You could change your Twitter handle, Seth Eliot.
I need to be that, yes. So as for the D-Day thing, I think that it's important to keep in mind that they actually had some very well-defined metrics on what success meant for that project.
That's true. They did.
Good, excellent point, and excellent lead into your topic, Seth.
Exactly.
Yes.
It's about the data. I mean, actually, I think, our modern military, I don't know a lot about it. When I do see, things come out of like discussions they've had on their projects. They are actually fairly data driven, but don't know a lot of details there. I'm going to talk about data driven quality. Data driven quality is something that has its roots in a previous topic I used to talk about, testing in production, or TIP. I know, Mark, you've heard me talk about that, and I think you interviewed me on a different podcast. I think down in Miami, and I think I said, my goal of talking about testing in production is to really scare folks into being aware of this. And then my second goal was that for them to stop being scared over time. And I think we've gotten there. I don't think you talk about, if you explain what testing in production is, and for those that haven't heard it, it's not just running synthetic test cases in production. It's about making use of production data. It's about mitigating risk in production, et cetera. So, if you talk about that kind of stuff, anybody who's been even vaguely aware of the blogosphere of what Netflix does, what Amazon does, what Twitter does, I don't think this stuff really should scare them anymore. So I think we've gotten there.
Yeah, I think we've crossed the chasm on that testing and production thing.
Yeah, that's what I hope. So data-driven quality. So testing and production was really about software services, and it is tied. I said Amazon, Netflix, Twitter, Facebook. It's tied to the rise in popularity of software services. And the thing why testing and production was possible with services is because the actual software is not hosted by the user, but it's hosted by the provider. And when it's hosted by the provider, they have access to the data. And they have access to being able to deploy fixes and deploy new versions pretty much whenever they want. And that enables you to, we'll see what's going on and fix it, and then see what's going on and fix that, et cetera, et cetera. So that's TIP. But then what is this data-driven quality about? Well, data-driven quality has two ways we're expanding on that, okay? Sort of longitudinally and horizontally. No, that's really kind of mixing my metaphors. So two ways. I said two ways. And now I'm going to stick with
There were two ways.
Exactly.
Way number one.
One is it's no longer just about services. We're seeing more and more that client software running on the user's resources is becoming more amenable to these techniques. In other words, it's always connected. There's a pipeline to the internet, a pipeline to the software supplier where they can get data and where they can deploy fixes down. I mean, you think of anything like in Microsoft's Office suite that, it's currently designed to be online, and we can deploy updates, and we can collect anonymous data about how it's performing and what it's doing. So that's one example of how DDQ expands on TIP to, encompass all software, not just services. And the other way it's expanding is, all these great techniques we came up with TIP. We have this, tons of data, lots and lots of data. What would you call it when you have lots and lots of data? There should be a phrase for that, you'd think.
I think it's called confusing.
Confusing. It's not small data. It's not medium data. It's not humongous data. There might be a phrase I've heard once or twice out there, or 5 million times.
Gigantamundo data.
Yeah.
Gigantamundo data.
Yes.
Yeah. It's yes. If you've done any DW work in your history, then it's the coined marketing department that came up with big data.
Oh, that's your voice being on the International Space Station as such. You are in a perfect position to say big data. Go say it again.
Big data.
Yeah, I stepped on you the first time. So
it's sort of like the we're going to turn the Metrodome into a giant mud pit for big truck festival thing. IT people don't really get muddy. So.
Saturday, big data.
Big data. Yes. So, you're going to have to see the world's largest sand explode with data. That's not exciting. A bunch of people sitting around a stadium just staring at a
screen,
machine in the middle.
So for those who are actually interested in some content instead of us being silly, big data is defined by 3 Vs or 4 Vs or 10 Vs or 20 Vs, depending on who you ask. I like sticking with 3 Vs.
Yes.
Okay. I might have to remember what they are. Variety, volume, and velocity. You got those 3 V's. You got big data. So anyway, You got all this data, and you're doing TIP, and you need to apply data science to it. You need to use statistics. You need to actually know what you're doing with this data. So if we're going to develop all these statistical methods, hey, we could use those also on all other data that we're using for assessment of quality, such as data that's happening before we go to production, such as test case results, right? I mean, we run a set of test cases, or this is a performance show, right? So you run a bunch of performance tests, right? You're like, in a lab running against some API, thousands or hundred thousands of times and measuring the 95th percentile latency. And you do that over and over and over again. Just by saying 95th percentile instead of saying mean latency, that's already applying data science, right? Means can be really deceiving and stupid and ugly, and they'll tell you 95th percentile is a little more interesting for various reasons. So,
or even knowing your standard deviation.
Knowing your standard deviation, exactly. So let's apply some data science to our data, even pre-production. There's some interesting stuff going on at Microsoft where, this is where I even mentioned this in talks I give, where they're using Bayesian analysis on test case results, pass-fail test case results, to determine which tests are actually giving value and which ones are just wasting our time. So, and don't ask me what Bayesian analysis
Mark, why does that? Why does that topic of tests giving value sound familiar?
It's in every show that you've ever done, James. Yeah. So the thing that's really interesting to help folks kind of take the step from performance testing as a part of the promotional traditional app development, Seth, the idea that we're taking a guess as to what we think performance is going to be like in the real world. We do some proactive tests. And I think one of the biggest things is really understanding how does the data, like you say, pre-production, how can we use the same types of measurements and calculations post-production and start connecting the two so we can learn from what's happening in production and make that influence our test design and our understanding of the value as to whether a test is accurate or not, or whether it actually helped or not. Is that, like, in a promotional aspect, is that where you connect them? Or is it also just learning from production, like through analytics, and bringing that back?
Well, all right. So I'll start answering that by answering a question you didn't ask, and then I'll answer the one you did ask, which is talking about this pre-production type of testing we do versus the post-production kind of data we can collect. And I'm glad you brought that up because they're complementary, right? People sometimes hear me talk, and they know I'm the testing and production guy, and they think, that means don't do any testing up front, just throw it in production and see what happens. And that's, of course, not what I'm talking about. So these are complementary things. What happens when you stand up your software in a lab and you put it on the top, two browsers or two mobile operating systems or whatever, that you're going to be on, and then you pump synthetic data at it and, watch to see if it croaks or measure the latencies. That's useful data, and it's telling you, it could reveal some serious problems that you need to fix, and you go back and you fix them. That's great. But it's narrow. It's narrow but deep, right? It's deep because you have real tight control over it. But it's narrow because it's only going to be one or two operating systems or one or two browsers. So that's valuable. So then what happens when you get to production, you can then measure what actual users are doing in terms of the time it takes for various APIs or work streams or experiences to happen, the latency of those under real users. And you might have thousands or tens of thousands or millions of real users. And if you're collecting rich enough metadata, then you can then start slicing and dicing that by operating system or browser or location around the world, or, which, in some cases, I don't know about an app developer, but if you're hosting a big service, which data center is being hit. So you can slice and dice this data in all different ways. And now you're getting the breadth, right? You're getting data from every single browser or operating system used by your users. Now you can find the ones that are having problems and take that back and fix that. So that's the complementary nature of it. One is sort of deep and one is sort of broad. And they both
Seth, just to paraphrase, the key attribute here is that we need to be looking at the same data elements pre-production as we are in production, so that we have this richness of complement to our smaller data set. So we understand the quality in a controlled fashion. Once we get out into the uncontrolled universe, we know what should be an expected result in optimal conditions, and that way we can use this as a bench to evaluate every other piece of data.
I think that's part of it, but there is a sort of discovery aspect too. When you go into production, you're going to find things you couldn't anticipate and you didn't expect. That's the magic of testing and production. That's, my old users are weird. Being in the live environment is unpredictable and chaotic, because it is, right?
So then the outliers show up and they become interesting.
That's exactly right, because you're not going to test the outliers synthetically before you go to production. And those outliers, obviously, if something's only affecting 0.001% of users, that's useful data to know. I don't really have to fix this or not really worry about it. But it could be an outlier in that it could be an outlier in the sense that you didn't anticipate it, but it can actually be affecting a significant number of users that you didn't expect this to happen, or you didn't expect this race condition to occur. So that's the discovery aspect of it. And then to answer Mark's question finally is how does this roll back? We always say that the things you find in production that you could have found pre-production, you then add tests for those pre-production. Now, there are many things that you might find. Eventually, the ideal is to find everything pre-production you could find pre-production at a reasonable cost without having to build an entire duplicate of your production environment, and then find the rest of it in production. You never want to be finding bugs you could have found with a unit test in production, for instance.
Wouldn't that be nice if well, first it would be a great step if everyone had unit tests. I think that would be neat. Then you might start somewhere by saying, gosh, we really should. We're finding these unit bugs in production. We really should put together unit tests and connect them to our CI. But for those folks out there that aren't doing that, start doing that. To this point, Seth, I think bringing the data back, there's two things in terms of learning these anomalies, right? There's even a weird anomalous behavior can end up being a catastrophic bug that takes all sorts of things out. A blocker, you say a race condition, which is more and more common in certain operating systems, especially embedded systems. But even data blockers now, where you think, oh, this is a massively distributed set of data, but then you have either a massive query that comes through and sucks all the resources up, or you have one particular activity that's like, oh, all of the related data needs to be linked and updated at the same time, and that can be a blocker.
Or Mark, I'd like to bring up a very common condition these days, which is that your percentage of your mobile population is higher than you anticipated pre-production. And so their latch time on resources is a lot longer. And as a result, you're exhausting the server.
We love bringing that one up, Seth. That's always a good one. You learn the real stuff about your mobile population. And mobile is pretty scarce in functional and performance testing pre-production, like really understanding the breadth of devices now out in the wild.
That's exactly right. I mean, you talked about a massively distributed data structure. You're talking about mobile, something running in a mobile environment. Both of those things are going to be really challenging to test in the lab. Again, and we don't say don't test them, but I mean, you're really not going to. I mean, massively distributed data by definition is massively distributed. So you're going to build a lab that can accommodate massively distributed data. I mean, that's
probably not.
Yeah, it's not reasonable.
Now, what do you think, Seth, about the other sort of from a performance perspective, not just with end users and client performance or experience from a system standpoint, but actual behaviors, the analytics portion, because of what the real world looks like, and bringing that back to make sure your existing tests can be improved based on what you learn, not just a missing test.
Right.
But you can make your test more accurate or more close to what the real world is. And that's also another use of improving the quality or the scope of the test as part of DDQ.
Yeah, I think so. I mean, like the case I gave where you're doing some happy cases on some known configurations in the lab, and you take it to production. Well, production showed you that your happy cases or assumed popular configurations are not actually what's happening and not what's being the most used, then you want to update your in-lab cases to reflect those, right? And you can even go so far as to take production data. And remember, everybody's, especially with the NSA thing, has to be very careful with data. And when, I'm going to say this here, and it goes throughout this entire conversation. How you handle data is you have to be very careful. You have to not, expose personally identifiable information. You have to scrub certain types of data, et cetera. So people, know handling data comes with responsibility. But if you know there's responsibility, measure some real production traffic. Take that production traffic back to the lab and use that copy of the production traffic as your in-lab testing. That's one way to improve your in-lab pre-production tests.
Seth, we need to take a quick break from our sponsor, but we will be right back.
Hosting for PerfBytes.com has been provided by NUCO, New Centers of Excellence in Performance Engineering, PowerTest Professional Services, The Script Farm, LoadRunner by the Hour, Videratech, Cloud Architect, and No Load Test. For more information, go to www.newcoe.com or call 703-856-8187.
And we're back.
That product or service I just heard about, I highly recommend it.
Do you? That's good.
That's because thank you, Seth.
It's James's company. Thinking about the whole life cycle, Seth, our main customer as testers is typically our brothers and sisters in development. And it could be a product owner, and we also equally represent the end users and sort of protecting their interests. I mean, testers can be very confused in terms of having serving multiple masters, I guess is a way to think of it. Who are the other customers in the IT world of these data-driven quality? What are the different roles? Who are the different stakeholders that you would pull in to take part in DDQ, and why?
I mean, so I'm going to take some exception with this whole developers are our customer. I know a lot of shops still operate that way, but any of the really modern-looking, efficient, producing high-quality software shops I know don't operate that way. Developers are not, test is not serving developers. In other words, testers, developers, PMs all have the same goal, which is producing high value to the business with the software, which that's our common goal. So we work together as partners on that goal. And towards that end, you want to talk about different roles and stakeholders. One becoming more common type of division of roles I'm seeing is that developers own creation of the product and unit testing of it. Like you said, doesn't always happen, but we're taking that even further and saying they own a lot of the functional testing. I know that's a very controversial statement. Sure. I'm going to have to defend it, but they own a lot of the functional testing. So basically, they should be testing the heck out of it as far as they can go on their dev box, and even sometimes maybe in a simple one-box environment. And then it goes into the main build where testers are looking at end-to-end experiences and making sure that the code is instrumented so that we'd be collecting data in production. And I don't want to be too vague here, so I'm going to get more specifics. I mean, performance data is very relevant to the show, availability data, usage data on errors, crashes, all kinds of things. That kind of data to assess the user end-to-end experiences, and ahead of time, not just being discovery is part of it, but ahead of time understanding what those user experiences look like and what they need to measure to make those a success. Hence, my intro when I was talking about the D-Day example of having well-defined metrics, and implementing that so that when it goes to production, we have real data on whether it's working or not, and then feeding those that analysis back to dev. So I guess in that way, they are sort of our customer. I'll concede that, so that they could actually then code improvements to the product that are reflected in the data. Other stakeholders involved is, in my mind, software development is about dev and test, and then maybe program managers that help define what those customer experiences look like alongside test. A lot of data we collect from production can be used by design professionals, usage professionals, people that are designing the interface, people that are designing the look and feel, so they understand where people are going and what they're using. I'm sure that's not as performance related, but it could be actually performance related, because how certain scenarios perform affect how users react to it and what features they're going to use and not use. Absolutely. And then there's the business analytics side of it, where and I don't see so much mix there, so they're not really a stakeholder, but certainly there is a potential, certainly if testers are collecting all of this data, to share it with the business side, marketing side, so they could actually use it also. Although, as I said, that's not something I've generally seen yet.
Yeah. In an ideal circumstance, we should be providing that performance data upstream to the business analyst, just as the last risk gate before production. That's an ideal universe. It rarely happens, but we should provide that to them as a stakeholder. Unfortunately, not a lot of them understand how to absorb that data currently, because they're not looking at performance for the most part when they're building requirements as well.
Yeah, I mean, I think so. Okay, so yeah, in that way that you're defining it, those business people would be sort of Microsoft program managers. So yes, they're definitely part of that, an integral part of that loop. I agree.
Right. Now, you didn't mention the ops guys at all.
Oh, yeah, I'm sorry.
It's so sad. I mean,
actually, we're seeing a lot more DevOps, right? So where developers own a lot of that operational burden, and certainly the use of cloud services like Azure or AWS really enables that to happen, right? Those services cloud services are created so that the ops is abstracted away for the most part. But we still have an ops role here. Ops have always used production data to make decisions, but more in a reactive way. necessarily in a proactive way, but maybe it's being unfair though. I mean, actually, the good ops folks, I'm sure, are being proactive. The good ops folks probably are using machine learning to try to anticipate problems ahead of time. So anything that's happening in production is definitely going to involve either specific ops people, or an ops role, whether that's DevOps or whatever that looks like. And by the way, DevOps is doesn't mean just developers do ops. It means engineers do ops. So it could be developers test, whatever. So go ahead.
Yeah, it could get blurry at that point. But I think still the idea that a reactive team that's really making sure everything works in production and stays running is one interpretation. The second interpretation would be what's sort of the meta things we can learn from production and start building better quality suites and better guidance back to, well, here's what we really know about the quality of this particular combination of platform and client and connectivity and these objects and this particular release, and drive that back as either actual defects or as, commonly run tests that we would do on a regular basis to maintain quality levels. So Seth, for someone to get started, if they're not learning things in a data-driven way, what are the first steps that someone should take for an application? Let's say an application that's already released in production and things are kind of moving. You kind of pick up this new technique on the fly. How do they get started?
Yeah, I'm happy to talk about that, because the biggest mistake I think folks make is just to collect a lot of data and hope they find something in there, hope they find gold. And I did talk about discovery, but discovery is sort of your 200 level kind of thing. If you just look at a bunch of data, collect a bunch of data, and then you look for something, you'll see things. It's sort of like staring at the clouds. You'll see shapes emerge that are not really. That's not really a bunny. 10,000 feet above you. So that's.
Wouldn't it be nice if we could vaporize bugs in production the same way you can vaporize clouds with your mind?
Sorry, I'm just trying to picture a bunny and a bunch of log data.
Exactly. I see it. You just sort of see it in zeros and ones, sort of emerging old ASCII art, right? I don't know if the youngins out there listening know what that is.
Yes. Okay, so discovery is where you might start, and but that's just the first step.
Discovery is not where you want to start. You don't want to be wallowing in the data without knowing where you're going. The first step is to think about determining what your questions are. I mean, if you're a test professional, you already know what kind of questions you're asking, because you're writing a bunch of test cases up front to ask them. So now the nature of asking questions becomes a little bit different, right? It becomes more about, for this end-to-end user scenario, what outcomes are we looking for that would mean success? And based on those outcomes, what metrics can we tie to those that would give us a quantitative measure of whether we succeeded or not? So
if we tie this all the way back to Test 101, we're looking for those expected results and essentially where to go to pick them up as part of our test.
That's right, but expected results in this case might look like a 95th percentile for latency on this end-to-end user experience, right? The web page, or let's keep it, instead of just the page load time, is less than half a second 95% of the time. I mean, that's what success might look like, for instance. Okay. And you can revisit this. So this is an iterative process. So you ask the questions. Let's get it all out there, right? You ask the questions. You design to be able to get data. So you instrument, you put in practices so you can get data from production in a risk-mitigated way. So you design to get the data. You choose what data sources are important to you. Is it performance data? Is it usage data? Is it availability data? Then you get the answers to your questions, and you raise more questions, and now you go back to the beginning, and then you get more data, get more answers, get more questions. So this becomes an iterative process. So if I said, a half a second load time for 95th percentile, and we see that usage is dropping off above, 300 milliseconds, well, that's new data there, that maybe our original metric wasn't right, and we need to adjust our metric for what success looks like. So you got to be constantly learning in this iterative process. But so the first step, though, is determining your questions. Yes.
Determining those questions. And again, the next step is to learn some mathematical science or some data sciences to figure out how to gather the data. And mostly it won't be privacy data. It'll be metadata and things about objects that aren't specific to a given individual. And start learning how to munge that data and actually understand it, maybe even visualize it?
Yeah, I think there's a step in between, though. So
Okay.
this is the Seth disagreeing with Mark show.
No, it's fine. It's beautiful.
I think there's a step in between. The step in between is actually design your system so you actually can get data in a risk mitigated way, right? So number one, there has to be instrumentation. There has to be some the product has to emit the data that you're looking for so that you actually get it, right? And as a risk mitigated way. So what I mean by that, I mean that you don't take something. A feature, a new feature that you're trying to assess, the performance of, whether it's sufficient or not, necessarily throw it out to everybody, right? You might throw it out to 1% of users. That's a way of mitigating the risk. That way, if it turns out it's a real bad performance hit, you've now learned, A, oh, that's broken, let's fix that. And B, you've only kind of annoyed 1% of your users, and maybe even of those 1%, only a certain number of those even hit that bad case. So you've annoyed a lot less than if you just rolled it out to everybody. That's part of mitigating risk. Right. The other part of
now should people, before you go on, should people be thinking about adding that instrumentation, or should it be a mix of seeing what already exists? There could be existing beacons or things out there. You don't just want to keep heaping on.
Oh, no, absolutely. And, certainly instrumentation can be done wrong, and collecting data can actually impact performance if it's not done right. It could fill up logs on the disks and make things bog down. It could load down your network. Sure, there's absolutely a lot of things you could do wrong if you're just throwing in, a bunch of instrumentation. And we've all seen log files that are just huge and ugly and useless, right? So it's not just
absolutely.
Yeah. Right. So you definitely want to look what's already out there. That's part of being responsible in the way you do this. So
Seth, do you ever consider a minimal acceptable data set for the information you want to collect? Kind of like a tier 1, tier 2, tier 3 situation, and maybe you only run tier 1 in production and tier 3 in full diagnostic mode in a controlled environment?
Yeah, absolutely. Or you might run tier 3 when you roll it out just to this 1% of users, or you might have some beta users or whatever. Sure. Yeah. Mm-hmm. Yeah. There's definitely, you want to have that kind of, the ideal is to be able to turn on and off what data you're emitting without having to do redeployment, just with a configuration change. That's the ideal that we look for. And let me talk, this is an interesting case that I just thought about, is when you're collecting data, not from services, but from clients, let's say an app on someone's phone, you have to be very cognizant of the data you're collecting, because if you just collect a whole bunch of data, you're going to kill their battery. For people that are paying for Wi-Fi, you're going to be, incurring data charges for them. They're not going to be happy. So what we do for clients is we try to set up rules to aggregate and filter the data before it's sent over the wire. So what do I mean by aggregate? Well, if you want to collect performance data, you could start bucketing that up. Instead of sending every data point every time they hit this API over some period of time, collect the mean or the 95th percentile or whatever, and send that over the wire. And then by filtering, maybe I'm not interested in those 3 other APIs right now. I'm only interested in this one, so only send that one. You can even get more clever and say, if someone is battery is low, you don't collect any data, which introduces a risk of bias. And that goes back to what you were saying, Mark, about understanding data science. And you have to understand the nature of data integrity and what bias looks like.
Yeah, and thank you for correcting me. Actually, the first step is actually getting data that you can use, either if it exists or not. But describe, what's a use case where somebody, like you said, maybe their question is, let's look at which pages are over our SLA in the 95th percentile and start looking at page load times or object load times or waits on a given API call from a device by different device endpoints. These kinds of questions, you can start asking questions and quickly get lost. What's the compass that somebody uses to kind of bring it back home and impacting their testing on an everyday basis?
The compass is experimentation. When I say this is an iterative process, it's an experimentation process. Experimentation means getting things out there, assessing them, and then making judgments, changing based on that. Anybody out there who knows Agile understands experimentation. It's about, go through a sprint, show what you've done, get feedback on it, understand what needs to be done next, and do that, right? So that's your compass. You sort of have to take a stab at first. And in a lot of cases, like with mobile apps, you'll be using somebody else's platform that provides this data, so you have a certain data set available to you right from the start. But it's about taking a stab at that and then seeing, did you get value from that data? Were you able to answer the questions that need to be answered, or did you raise more questions? And then, iterating on that to decide what data you need additionally or instead of that data that you got.
Right.
So that would be basically, so where you get that first iteration could be a little tough, but just start somewhere that you're not going to be causing damage or taxing the system. Start with something and see if that gives you the value you need, or how much of that value it gives you, and then iterate from there.
So, Seth, I have a question. This type of big data analysis lends itself to consistent and repeated application over and over again. And what jumps to mind is really the use of expert systems and rules to actually look at the data and to highlight for the person who's doing analysis exceptions in the data. Even if you're not looking at it yourself, the system is identifying those items for you and pulling it out.
That's a great example. Yeah, it's a great point. And it also reminds me there's going to be multiple roles here, right? So there's going to be actually roles of folks that are, especially testers, that might really be interested in data science and be digging into it and actually creating these systems. And there's roles of the other testers that might understand the value of it, but just sort of be end users of the tools. You still have to understand something, but you don't have to be like data science PhD. So what you were saying about being able to identify the anomalies is hugely important. So an example I've seen is from the Exchange Online system. They're implementing machine learning on their errors. So there's various errors that get thrown off of the system. And each different error has its own kind of characteristics. Like, when does it peak? When does it go down? Based on time of day, based on type of user, based on data center, based on all kinds of different things. You see these different error rates. So it's not just like a flat line. You're looking for a spike. It's this crazy pattern, and now you're trying to determine, well, how do I see when this is broken? So yeah. So
or how do I proactively suggest that data center 42 is going to have an issue?
Exactly, and that's where machine learning comes in. And machine learning, if I is like the really high end end of data science. Machine learning, the way I describe machine learning to folks is it's just think about your high school geometry when you had an XY graph and a bunch of dots, and you drew a line through them. You drew a regression, and you got y equals mx plus b. Based on that line, you can now predict, given another x value, what the probable y value would be, right? That's what machine learning is on steroids. Only instead of necessarily being a little line, it's these very complex, multi-dimensional, multivariate functions. So basically, an example I gave of these errors with these weird patterns, basically, given all the inputs, machine learning can then predict the pattern and know when you're deviating from that pattern. Given the example you gave of when can I proactively predict that this is going to break, it's the same kind of thing. It becomes a prediction problem. If you understand the function, you can understand the next data point in that function.
Yeah, sorry, excuse me. I just listened.
That makes sense. Did I totally not make sense? I feel really like I must have not made any sense whatsoever. I totally stunned you into silence.
No. I think Mark needed to take another drink of his beverage.
I did take a sip. Sorry about that. So, Seth, that's exactly right. But I think even though your question is what drives you to get the experimentation in place where you can start recognizing a pattern that is estimatable. And I think what that has to loop all the way back to is not just the answer to the question. I think there's also the point of saying, at the risk of getting strapped on the back of Robert Persick's motorcycle and getting driven all the way across Montana, I would say quality is, meaning something. It's information that means something to someone. So once you learn something as a result of your experimentation, to know whether it's valuable or not says, wow, this is something that may impact our customer. It's something that may impact our goals for throughput, at the risk of being an ITIL guy, the old 5 nines world, and saying, all right, let's go after 5 nines in service management and things like that. Those mean something to either the business or to a human being in the real world. And I think that gets back to the question creation, but it's also something that goes from the qualitative realm to the quantitative realm and being able to go back and forth between those two domains with some credibility.
Well, this is why I think most of the future of data-driven quality is not about feature testing. I mean, certainly you can apply it to feature testing, but it's really about experience or scenario testing. And when you say the quality has to mean something to someone, that's sort of part of the scenario. The scenario has a persona. It has someone in it. They have their own environment. They have needs that they're trying to actually fulfill. Wow, this is getting weird.
Sure. No, that's right.
So from to take it back to data and, less about personality, because of the nature of the questions you're asking, it lends itself to a wider use than just one user and functional doesn't work, yes, no. You're looking at more subjective information. There's still a boundary on it, the 95th percentile, the 97th percentile, 99.9 uptime, but it needs more than one sample, and the closer you get to n-1, the better your sample set.
To me, it's a learning these techniques for data-driven performance, but data-driven quality generally, is a way for testers that may feel out of touch with reality to start building the relationships with the ops guys and really learning the data and taking steps to quantitatively understanding what the real world is estimated to look like, and then making sure that your tests represent that, are enhanced by that, and potentially even limited by that. So you might say, we test a whole bunch of stuff that doesn't mean anything. According to the real world, these are the kinds of areas that are the most vulnerable or the most frequently broken or dissatisfying or something.
And Mark and Seth, I'd like to throw out a location of data. If you want to get into this arena and you don't know where to begin, you don't know the questions to ask, I say ask ops and ask your help desk.
Yes, that's what I was going to say. No, thank you, James. That was a perfect tie-in, because when Mark said tying it to reality, he mentioned ops. Yes, ops is one part of it, and the other part of it is the customer. And even if you don't have direct access to the customer, yes, the help desk is a great source of data, and actually any tester is not making use of that data is leaving a lot of chips on the table. Because, there's like an example I give in one of my talks where Visual Studio found out about a problem and it's for slow load times by looking at the forums. And by looking at the forums, then they were able to implement a solution of asynchronous loading. And by that point, they'd wised up and actually instrumented it so they can measure how long it was taking to load. But that data from the forums told them two things: fix it and instrument it. But so there's that. But the other way of contacting customers are other ways too. If you don't have direct contact, there is somebody in your company that does, the business owner or whoever you call them. Ask them for what is their data about why you're producing why the specs say what they do, why the requirements say what they do. Show me the customer data that says this is meeting the customer need. And then once you show me that, I'll be better able to instrument the product and assess whether it really is meeting that.
And maintain it to some extent, maintain the numbers, whatever those goals may become, or generate new questions based on what you just learned, and experimentation leading more experimentation after that.
Yeah, I'm afraid that a lot of testers don't feel empowered to do what I just said. Hopefully they feel empowered enough to go to the support desk. Some of them might not even feel more empowered to that, right? They're afraid their manager's going to say, why are you talking to those folks? And certainly going to the business owners and saying, show me your customer data for why we're doing what we're doing. This is something we actually are trying to build at Microsoft. But I can see at a lot of shops that someone just might not feel like they have, the high enough rank to go there, and that's unfortunate.
The freedom to go there, and it's similar things we see in the performance testing world, where some folks they're not allowed to even monitor systems while they're testing. It's just ridiculous. And you can call James and I up at any time, and we'll argue on your behalf because we like that. So getting access to this metric data and the analytics data, as well as instrumentation data about that, goes right along with being able to correlate that with all the monitoring statistics.
And the customer design data. The data that's collected even before the product's built. Because, if you tell me there's no data collected on the customer before the product's built, I would ask you, why are you building this product?
Oh my gosh, yeah. There is a gap, and it may be kind of dirty.
There's a project manager who needs a project.
Yeah.
Which brings us full circle to them signing a letter of complete accountability before we go into D-Day, right?
Again, exactly. I think there was plenty of data on why we were doing D-Day.
Right? Yes, you didn't have to look too far to figure that out. So we're kind of boiling down to the end of our episode at this time. And Seth, is there something else you would like to share in closing about data-driven quality for performance?
Well, I mean, the data sources, are very varied and depending on your needs. And they could actually, we didn't even talk about synthetic data. I mean, you could actually be running synthetics in production and having them generate data, and there's usefulness to that too. But in general, I think you just got to start by getting out of the running test cases pre-production against features mentality. If you could break out in any angle, whether you're breaking out of the features mentality or breaking out of the pre-production mentality or breaking out of the using test cases mentality or break out of all three, it's a start. And you're going to be moving yourself in a direction that's going to deliver you higher value.
Beautiful. James, any last questions to grill Seth with?
I don't think so. I think we've covered the gambit of what it is, how it's useful, where to get started, how to carry it forward in an iterative process, and also potentially some external sources to turn to from Insight if you need a challenge on where to start.
Yeah, and if you just need support in order to build that relationship, or you finally need a better relationship with the ops guys or the business guys, this is a good discussion. And there's more information. Seth, where can folks find more information on data-driven quality? Back.
Yeah, if you go to SethEliot.com, that's 1 L and 1 T, there's sort of a big list of my presentations and papers there. So that's a decent place to start. And in any presentation I give, it's just full of references. So I'm not just sort of, pushing myself. If you open up any of those decks, everything I mention is referenced. So it'll just sort of give you a lot of places you can go to read about this.
Right. And they can also, we mentioned tips, so they can actually go to some of your older presentations to connect tip and DDQ.
Yeah. If you look at any of the old TIP presentations, they're still going to tell you a lot of useful stuff. That basically TIP is one piece of DDQ.
Got it. It's a beautiful thing. All right. Well, PerfBytes listeners, once again, you have come to the end of yet another fantastic, mind-melting, data-driven episode of PerfBytes. And as always, we'd like to thank you for taking the time for listening to the show today. And of course, extra thanks to Seth Eliot, the most awesome principal knowledge engineer in the universe, for joining us. Seth, thanks.
It's been my pleasure. Yes,
Seth. Thank you so much for taking time out of your weekend for this. We do appreciate it. And I also want to extend a thank you to my mother. It is very comforting for us to know that we always have at least one listener.
Yes, thank you to James's mom. I will thank the sexy Irish voice of PerfBytes, Martha, who's down the hall doing dissertation work, and so I'm still stuck. Well, we're both on the International Space Station. But I forgot to say, Seth, is there anyone you want to give a shout-out to?
Well, I mean, as long as we're, thanking family members. I mean, my wife, Danielle, is a great supporter, and she's my editor. Since she is a romance novelist, she has some skills in being able to edit my material and maybe make it a little saucier.
Ooh, that's nice. Yes, data-driven quality. A little saucy for you.
Sorry, I'm visualizing Seth as Fabio on the front of a book. So
that sounds good.
Just imagine throbbing data. It's great.
Yes. Well, special thanks to our great sponsors, Flood.io and Cubic Load Pack, for their continued sponsorship of the support of the PerfBytes show and the PerfBytes community.
And Mark, I'd just like to let you know that today's show is powered by the number 42.
Deep thought. That's excellent. Yes, exactly. Please remember that this and all content of the PerfBytes episodes are copyrighted and protected by a combination of green M&Ms and red M&Ms. And if you put a green M&M and a red M&M together, they don't become a purple M&M. I don't know if you know that. But that simple knowledge that green stays green and red stays red is how we protect all of the content of PerfBytes. Just want you to know that.
Mark, for more information about PerfBytes, please visit the show's website at www.perfbytes.com or follow us on the Twitter and the Facebook. And of course, you can always subscribe and listen to the PerfBytes podcast on iTunes, TuneIn Radio, Stitcher, or iHeartRadio. Just open up your favorite listening app and search for PerfBytes, click subscribe, and there you go.
Please keep in mind the PerfBytes show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, a computer measurement group, the Workshop on Performance and Reliability, and of course the Software Test Professionals community of software testers, where I first met Seth Eliot. And we hope to see you at the next STPCon conference coming up in November in Denver. And we're going to have the first Mile High PerfBytes episode. That should be very exciting. And we don't mean like the use of cannabis high. It's just like actual elevation from sea level.
Not that there's anything wrong with that, though, in Colorado.
No, it's perfectly legal, of course, but we're not into that. It's mostly single malt scotch, as you know, Seth.
Yeah. 1 month from now, we expect all of you to be at my place in Monroe, North Carolina for the PerfBytes annual barbecue. Everybody gets a door prize. Please let us know that you're going to attend so we know how many door prizes to buy.
Yeah, I'm going to be there. I'm going to bring along some rare single malt scotches. It would be great. And then I'll be, in August, I'll be teaching at CAST in New York City. I may also be doing a Whopper 23 here in October. And then, of course, STPCon, we're going to see everyone there. This should be awesome. But it's summertime. Get outside. Enjoy the weather. And thanks again, Seth, for joining us. It was really great to dig into the topic with you.
You're welcome. It was a great conversation.
Thanks, guys. We'll see you in the next PerfBytes.
Have a great week.